Hello everyone, welcome once again to this series of video lectures on unsupervised learning and algorithms under this kind of learning. My name is Priscilla Chamenyi. I am a junior data scientist for global communities in the Laboratory of Data Science at Purdue University, Fort Wayne. And I'm going to be your miss for today. In the last video, we looked at hierarchical and spectral clustering. In today's video, we're going to continue by talking about DB-scan, which is also a clustering algorithm. Now, DB-scan, that's density-based spatial clustering of applications with noise, is a density-based clustering algorithm that is used to identify clusters in a dataset. It does not require the number of clusters to be specified beforehand, unlike k-means, our popular traditional clustering method. And this method uses a density-based approach to identify clusters of similar data points. So now we're going to go into how the whole thing works. The basic idea of DB-scan is to identify clusters of data points that are densely packed together. It chooses a random data point from the dataset, and then it finds all data points within a specified radius. That is also known as the epsilon parameter. If the number of neighbors meets or exceeds a certain threshold, which is known as the min points parameter, and then we form a cluster. It continues to find all data points within the same radius for each point in the cluster. And this algorithm repeats the above steps iteratively for each data point in the data set until all clusters are identified. Now, we're going to look at the algorithm. So now the algorithm takes two parameters as input aside the data set that is already going to be taken in. And the two parameters I already mentioned were the epsilon and the min points. So I'm going to talk a little bit more about the epsilon. So the epsilon parameter is the maximum distance between 2 points for them to be considered as part of the same cluster. Now, this epsilon is going to define the neighborhood around that data point. And usually for small epsilon, if we have a small epsilon value, that means that a large part of the data will be considered as an outlier. And when we have a large epsilon value, then the data points will most likely be in the same cluster. Now, this epsilon parameter is decided by the user. Just to put that out there, the user decides what maximum number or what maximum distance they want to put in for the whole algorithm. The second parameter is the min points parameter, and that is defined as the minimum number of points that are required to form a cluster. Now, large data sets imply large values of min points must be chosen. And as a general rule, the minimum min points can be derived from the number of dimensions in the data set. So your min points can have a general rule. The min point, has the general rule that it is greater than or equal to the number of dimensions in your data set plus 1. As the algorithm proceeds, it classifies each data point in the dataset as one of the following. So you will either have a core point, you would have a border point, or you have an outlier. Now, when a point is a core point, then we say that that point has at least min point within the epsilon distance from it. This is basically saying that if I choose my epsilon distance or my epsilon radius to be 4, and then I choose my min points to be 4 min points, then I'll have a core point if when I use that 5 centimeters and draw a circle around a data point, that point has at least 4 points in its neighborhood, then that point becomes a core point. I hope it makes much more sense what I'm saying. A border point is a point that is within the epsilon distance from a core point, but does not have main points within the epsilon distance from it. So this can also be called a non-core point. And then outliers are points that are not within the epsilon distance from any other point. So if I have defined my epsilon to be a radius of 5 centimeters, it means that when I pick any data point and I draw a circle around it that has a radius of 5, points that are not anywhere around that circle would be known as an outlier. For a core point, when I pick any point and I draw a circle around it with a radius of 5, if that circle is able to capture at least four other points, then that point that I have drawn a circle around is a core point. Now for a border point, then if I have a core point, if I have a point and I draw my radius around it and it captures points that are not up to 4 points, then it becomes a border point. I hope that gives a little clarification. So they will not have border points, will not have main points within the epsilon distance from it. That means that when I take that point and draw a circle around it, I will not have main points in it. The advantages of this algorithm is that it can handle data sets with varying cluster sizes and shapes. It also does not require the number of clusters to be specified beforehand, and it works well with data sets that have noise and outliers. And then it can also identify clusters of arbitrary shapes. And the downside is that it is sensitive to the choice of the epsilon and main points parameters. It can be computationally expensive for large data sets. It cannot cluster data sets well with large differences in densities, and it can be affected by the presence of noise and outliers in the data set. Now this is an example code using DB-scan algorithm. The data set is the iris data set in R. Each data point represents an iris flower, and it consists of 150 data points, so that's 150 iris flowers. Then it has 4 numerical features, which are the sepal length, the sepal width, the petal length, and the petal width, all measured in centimeters. And the one categorical feature is the species of the iris flower. So whether it's an iris setosa, an iris veriscala, or an iris virginica. Yes. So this algorithm is in R, and as you can see, I called in the dataset iris. Now I called in data and excluded the 5th column. The 5th column of the iris dataset is what it includes is the species column, and since we want to only cluster the numerical column, we take that column out. Now, as I said, the parameters epsilon and main points are user specified. So in my code, I specified the epsilon parameter, that's the radius, and then I specified the minimum number of points in the cluster, that's 5. And then I run my DBS scan. So let's take a look at the output. So I have 3 different clusters based off the epsilon and main points parameters that I chose, as you can see. And I'm going to put this out there and note that the value chosen for the epsilon and the main points parameters affects the number of clusters the data set will have, as well as which data point will belong to which cluster. So if I'm supposed to switch around and change my epsilon value and change my my main points value, I'm going to have a little different set of parameters. It could even clusters. these clusters could even be reduced to 2. So it's all dependent on what you are doing, the data set you are working with, and how you want to go about getting your number of clusters. Yeah, and so that brings us to the end of today's video lecture. This work is brought to you by the Laboratory of Data Science and the Indiana Data Mine Grant, and it is supervised by Professor Alessandro Selvitella. Until we meet again, I'll see you next time. Bye.